This video is on public key infrastructure. Before you use your browser to go to a website and create an encrypting connection, you must first engage in a process known as SSL handshake. One of the most important parts in SSL handshake is sending of the server certificate to the web browser. It's where the web browser is able to authenticate the identity of the server it's connecting to. Secure socket layer requires a PKI certificate on the server to prove its identity confidentially to the client. Every HTTPS web server connection uses SSL. For you to get a certificate, you must first generate a private key public key pair and submit a CSR to Certificate Authority, which stands for Certificate Signing Request. The contents of CSR will form part of the final server certificate. The Certificate Authority then verifies whether the information on the certificate is correct, and then signs it using its private key, and then returns the signed server certificate back to you. You then import the signed server certificate onto your own server. A registration authority is a firm or organization that receives and validates digital certificates and public and private key pair requests. PKI Certificate Authority is a secure third party that issues PKI certificates to individuals after checking their identity. They're the one who signs these certificates utilizing its private key. So what does this PKI certificate consist of? Well, it contains individual's public key, its motivation, the certificate authority that approved and issued the certificate, the date, and the algorithm utilized to create the signature. You basically call this certificate attributes. Every device includes something called a root store. A root store is a collection of pre-downloaded root certificates and their public keys that live on the device itself. Generally, the device will use whatever root store is native to its operating system. Any certificate signed with its private key will be automatically trusted by the browsers. Then we have end-user or leaf SSL certificates, which have shorter lifespan compared to the root certificates. Server leaf certificates or so-called end-user SSL certificates directly off of their roots. The roots are too valuable and there's just too much risk involved. Certificates authorities generally issue what is called intermediate root. The certificate authority signs the intermediate root with its private key, which makes it trusted. Then the certificate authority uses intermediate certificate's private key to sign and issue end-user SSL certificates. Certificate store resides on a local PC and stores the issued certificates and private keys. The certificate database stores all these certificates endorsed by the certificate authority. Do note that certificate may have subject alternative name, in addition to common name, which represents the server name protected by SSL certificate. It is a certificate that supports various domains in the same certificate. It's common to see a single certificate cover both the root domain and the subdomain. For example, google.com and www.google.com. This is a X.509 standard extension. X.509 specifications regulate the Internet X.509 public key infrastructure certificate, which includes the SSL certificate format. Also, do note that certificates have expiration date, and you will need to renew your SSL certificate prior to the expiration date. Usually, this is done automatically. Certificates can also be revoked. A certification revocation list is a digital certificates that have been revoked by the issuing certificate authority before their actual or assigned expiration date. The Online Certificate Status Protocol is an internet protocol that is utilized for obtaining the revocation status of an X.509 digital certificate. So everything that puts all this together is what we call public key infrastructure. PKI, or public key infrastructure, is a set of hardware, software, people, policies, and procedures needed to create, manage, distribute, use, store, and revoke digital certificates and manage public key encryption. Simply put, it's what permits users to securely exchange data over the use of private and public cryptographic key pair that has been obtained through a trusted authority.